So here we've got a parametric curve, and the curve is called the curve C, and it's defined using the parameter t, which is any real number, x equals t minus 9 and y equals 6 minus t squared. And what we want to do is find the Cartesian equation of this curve C. So what we're going to do is try and get some sort of formula, in this case in terms of y equals, and we've got here 6 minus t squared. But what we want is this in terms of y equals some function with x. So here, this is our x, it's t minus 9. So what we're going to do is first is get the t isolated from this equation here to determine x, and then we're going to plug it into here, and then we'll see what we get in response to that. So x equals t minus 9. Let's isolate the t, and then that will give us t equals x plus 9. That is then what we're going to plug into here, because if t is equivalent to that, we can just substitute it into here. So then using that, y equals 6 minus, I've got to be careful here because I've got this squared and the minus here. So if I open up a bracket and put that in there and then square it, so then that will be equivalent without the parameter t. So now what we're going to do now is expand this out. So then y equals 6 minus, let's keep the expansion inside a bracket. So expanding this, I'll have x squared plus 18x plus 81. Okay, now that is not incorrect at all, but it's still a little bit clumsy looking. So we're going to just distribute this minus sign inside here. So now y equals 6 minus x squared minus plus 18x, that gives me minus 18x, and then minus plus 81, which is minus 81. And all that's left to do now is just to simplify that. So then I've got y equals, so we do it in terms of the orders of the indices of x. So I've got minus x squared minus 18x, and then I've got minus 81 plus 6, so that'll give me minus 75. And then we are done in terms of finding our Cartesian equation of C. Okay.